Hi everyone, let's talk about attribute tables for a moment.
Let's open the attribute table. Easiest way, right-click, attribute table. And the attribute table now will appear at the bottom part of your display. You can also put it somewhere else. This is again a window that's just simply been docked. You could have it free-floating, but it is usually a good idea to have it where it was. And so I'm docking it back in here. And we can have multiple attribute tables open. Let me open up a second one here. And so the default is that the two are overlapping. You can switch between the two attribute tables. And if you want to see them side by side, you take either of the two and you simply drag it to, in my case, the right side here. And now we're having both tables available for inspection. The good thing is that the attribute tables are always in edit mode, so we don't have to go into a special edit session. Let's just do one quick little edit here. Let's find out here this buffer area. Let me select it first of all to see what we're talking about. So I'm selecting it, and up here I can zoom to the selection area. And so here is my buffer area within residential areas, and I simply want to change this here and get rid of the official and simply call this a buffer area, and hit enter, and it's edited. However, it is not saved yet, and you can look for a long time within these attribute tables where there is a save button, and the save button is not here. The save button actually is under the edit button, the edit ribbon. Here is my save. So please remember, when you edit your attribute tables, your save is always here in the top ribbon under the edit tab. Save all edits, yes, and now this has been permanently saved. The other thing, of course, is that within an attribute table, and let's go back to the last viewpoint here, I can select a school, and I can find the selected row in here. But if you go to the selection tab down here, then only the selected schools will be listed. So that updates automatically if you select now a different school, or if I hit the shift button down and I select the second school, and now we have both attributes in here, and that is extremely handy. Always make sure that you are aware on which side you are between this one here and the selection one. To close it, you simply click the X to X out of your attribute tables, and you are back to where we started.
When you open up your attribute table, right-click and attribute table, you see your table organized here. So we have the fields across, so the fields are the individual columns. We did talk about field names and the restrictions. And here you see the individual records. So it's one of the important parts of organization of a GIS that you have exactly one record for each feature that's in the map, be it a point or line or polygon or a certain raster code, for instance. And so that means that's where your information, the intelligence is stored, and you need to be in control of what to do and how to select things from your table. So let's just look here. There's one table open right now. We can open multiple tables. Let me open up here also my green space attribute table. And so now you can flick between the two different tables. But if you wanted to see them side by side, what you do is you click on any of these, and you simply drag it to your docking icon where you want it. And in this case it's side by side, and of course you can decide which table you give more space and which one less space. In each table you can still see all the tables by using the slider bar, and here near the bottom you can zoom in and out of your table to see maybe more or less. So if you wanted to select something, you can select, of course, in this case let's select some schools. So you can click on this. In this case here one school has been selected, and this can be troublesome when you have a long table with hundreds or thousands of records. Where are your selected ones? And what is really handy here is at the bottom left of your table window, there you can go. Right now we have 1 of 37 schools selected. If you go to the second one, you show only the selected records. There you have it, that you can see only the one. And now if I flick here to other ones, select other ones, or I select a whole bunch, then you can see here those selected records. A few more comments about selections. You can select, of course, by clicking here on the gray part of a record here. You click with your mouse, and if you hit the control button, you can select multiple features directly in the table. Or, as you will remember from the File Explorer, for instance, you select one, and if you hit the Shift key at the same time, you can also select all the records in between. One thing that's interesting that you can do, you can switch your selection. So imagine you only select, let's say, these 3 schools here, and you want to reverse the selection, anything but these 3 schools. You can do that by selecting the switch here. You switch the selection, and now everything that was selected is unselected, and vice versa. Let me clear my selections, and I can do that either here where I did it, or up here in my ribbon. We can make a connection between which features are displayed and which ones are shown in the table by adding on this spatial filter. So this one here says extend filtering is disabled. If I enable it, right now we have 37 schools, that's all in Lethbridge. And if we zoom in, only those schools that are within the display are now shown here in the table, which is only 16. Let's zoom in a little bit further, maybe just to these 5 here. There. And now only these 5 are displayed. So that can be very handy if you have large records. Let's undo the filter again. We have all our 37 features back in our attribute table. And now let us select any. And now what we can do is we can zoom straight to that particular school. We can also zoom to a selection of schools, and then when we do that, it makes sure that it goes to the best extent to fit in 1, 2, 3 selected schools in this case. And so zooming to your selected features is a handy feature. Let's work with the individual fields. We can access the field information by right-clicking on any of the field headers and clicking Fields. And now you see the individual field attributes. For instance, your data type, which is important, what kind of format you have, how many spaces, length, and so on, precision, scale. And also you can decide which fields are visible or not. Let's just make a number here invisible right now. So we're not deleting them, we're just not showing them in the table when we display them. These change in settings. We have to save up here at the top ribbon. Hit save. And now if I look at my table, there you can see that those fields that were available before are gone. And of course I can go back to my original settings by making them visible again and hitting save, and there they are back again. This field name is not a very good field name because it tells us it's the area of a shape, but it does not contain the units. So we could guess, is this square feet, square meters, square yards, acres? What is it? We want to know, we need to know. So the best way to double check if you see an area field that is not clearly in a geodatabase which is updated, if it's part of a shapefile, it's a good idea to recalculate that field. We do that by right-clicking and saying calculate geometry. And now within our geoprocessing tools, the calculate geometry attributes tool is open, already pre-filled in for the input feature and the target. And now we have to decide what property do we want to calculate. We want to have an area. The area we want to be in meters, square meters, and I want to use the current coordinate system, which happens to be the coordinate system that is used by the city of Lethbridge, and so that's why we adopted that. And we hit run to execute the tool, and we can see that the area actually has not changed. So it was in square meters, but before we didn't know, we were guessing, and now we are certain. So let's add a field and calculate acres. Have another area field that is called acres. So we click here on the field add button, and then again our field view comes up, but in this case here at the bottom there is a new field. It's ready for some input, and I want to call this area, and I like to add the units right in my field name so there is no more guessing. The data type, I want that to be, double click here, I want this to be a floating point because I don't know yet what numbers there will be in there. It's also, of course, numeric. That's all I have to say. Enter. And now to add the field to my table, I have to go back to my ribbon up here and hit save. Now my green space shapefile has a new field called area in acres, and we need to now calculate the area. Calculate geometry. We open the same field again, a new field here. Property is again area, and now the units must be in acres. Coordinate system and execute the tool. And that's how you calculate the area of a newly added field. There are countless situations where you need to add additional table data to your feature attribute table. And we can do that with a join. In our example here we have Lethbridge and we have some census tracts, and let's just make them better visible. And here I have my census tract polygons, and I want to add the recent census data to this attribute table. Before we can execute the join, we need to investigate the attribute data. So let's open up our attribute table here first. And in here we can see there is a field. It's called tract ID. That stands for census tracts ID. And we want to investigate what's going on here. So we have 171 polygons. And if I sort by double clicking, we see the lowest number is 101 and the highest number is 951. Also, what we can see here, that there are two polygons that have the same number. This could be a mistake, or maybe it's an order. Easiest way is to investigate. Let's quickly select those two and zoom to those selected polygons. And what we can see here is one polygon and there's a second polygon. They are connected, only here at the very corner. So they're actually individual polygons, and so therefore actually the database, okay, they just happen to have the same census tract ID number. The standalone table that I have already added to my table of contents is listed at the bottom of the table of contents under standalone tables. Right now I only have one, but there could be multiple tables in here. Let's also open up this table, right click open, and let's look at them side by side. I drag this here into my docking icon on the right side to see them side by side, and here are our census tract data, all about male and female data at various ages, including at the end total males, total females, and total citizens per census tract. Now we cannot find in here a field that's called tract ID, and it doesn't matter. When you join fields, the field name doesn't have to be the same name, but the field type has to be the same. In our standalone table, we find a field that contains our tract ID numbers. Unfortunately, it's called area, which is a horrible name for this field, really confusing for everyone. But we can see it has also the lowest number 101, it has the highest number of 951. It also contains one additional field that we do not have in our attribute table, that contains the total numbers, the total statistics, the sum of all our individual fields. This record will not be added to our attribute table. So now we are ready to carry out the join. Let's just clean up a few things here. We don't need this table open here anymore. And also I want to unselect my field, so I can say just clear my selections. Let's carry out the join. Right click in the table of contents on your feature. You go to add join. Our join tool opens up. We choose our common field. There's only one join table here that is available, therefore it's correctly filled out. It chose the first field that it could find, that may be a contender. It is correct in this case. You always want to keep all target features, because if there is a missing record here in your standalone table, it would now also delete that record in our polygon. We don't want that. And we hit run. And after a successful join, you see that the feature has disappeared from our display area, and we have added fields. All our fields that are in here now have been added. And the last important step we need to carry out is take our feature file and simply save it as a new file. We export the features. Our feature class to feature class tool comes up, and we simply give it a new name and a correct location, of course. Let's call it LB Census 2015, and I hit run. And we can close our attribute table. There is our polygon file with the census district. They're identical, the two. And if I open up the attribute table here, all our joint data now have been permanently added to the field. So now we can start making maps with this. The last thing we want to do here is go to our census tract data and remove the join again, because we don't need it anymore. So remove all joins. And now my original file here, if we open this attribute table up now, of the original file is back to where it was before. And the join, of course, now allows us to map our census data. Let's quickly make a map of the elderly in Lethbridge. Right click, symbology.
We want graduated colors. Of course, we can change the colors and the class breaks and all this and the number of classes. It's not about this today. And let's just choose here the oldest females for argument's sake. And there we see where the oldest females live. And in these sections, we find, of course, our seniors' homes. So this is how you add new data to existing feature files through a join so that you can analyze the data and symbolize them. In this example of an Esri tutorial dataset of California, we try to add a dataset about recreational areas per county. So we have a polygon file about the counties in California. And if we open up the attribute table, we can see we have here county ID, county name. Let me sort this. And if we open up the recreational data set, standalone table, again, let's view them side by side. There we see, if we open up the very first one, Alameda, that there are 4 records, but there's only one polygon with that name in our feature file. And so here we have a cardinality where we have many records in our standalone table, but only one record in our original file, and therefore we cannot add 4 pieces of information to one single record. That's impossible with a join, and therefore we have to relate the data sets. We relate by right-clicking, joins and relates, and here now I want to add a relate. California, and the input name is correct. The relate table is REC. The input relate name is country name. It's all correct so far. Let's give this a name. So we call this rec2 cal, and the cardinality is already declared as 1 to many records. Run it. Nothing happens because we only have done a relate. No fields were added to any other table. And now we can do our query. And right away after our relate has been executed, we can now select a polygon, and we can see that instantly now these selected records are related. If I just turn on here now, show only the selected records, we could now go through any of these polygons, and we can also select a polygon from the map, of course. Select a polygon here, and the moment we select that, you can see now the associated, in this case, recreational areas that are associated with this one county. In order to make some kind of map of our recreational areas, we can maybe calculate some statistics from our field and add the statistics then via a join to our polygon file. So let's see what we can do here. First of all, I want to unselect whatever I had selected. I clear my polygons, make sure nothing is selected for my analysis. And I want to also see here all my recreational areas. Let's carry out the statistics for our field. Here, right-click, summarize. I have here my statistics output file. I choose my field to calculate the statistics on, and of course here a field that contains text. We cannot do any statistics on this, but we can do one thing, and we can count how many records we have per individual county. We can use the rest of the defaults here and say run. Here's our output statistics field, and when we open that, we can see now the count and also an automatic frequency field here for our table, and now we can join these two together. Let's do the join. Let's turn these ones off. We can see here now we have now added numbers, and of course now we can use these numbers to visualize. So we quickly do a save, and then we symbolize what we have just added. And here is our map that is now useful in terms of how many different occurrences of recreational area we have across California. It doesn't make sense to map the actual population data because the census tracts of different areas. What is much more meaningful is to calculate the population density. That's easy to do because we have the data in our attribute table. We have our area field in square kilometer. That's a really meaningful field name. And we have our total population. Let's add a field. And let's call it pop dense square kilometer. And you see now when I exceed the number of characters in my field name, then this box turns red and my save button up here is grayed out because here is a mistake that is not accepted. Let's just make this a little bit shorter. P dense per square kilometer, that's a good name. And the data type, I would like this to be a floating point, because I don't know exactly what the numbers will be. That's all I need to add, and I save my field information to now add the field to my attribute table. I can close my fields, and here is my added field. And now I right click and say calculate field. The output table will be updated. The field name is here. The expression type Python 3 is correct. We can use that. So here, what is the population density? It's simply the C total, double click that, divided by area in square kilometers. Again, double click it. You see that in our syntax here we have exclamation marks before and after our name. That is the Python syntax that we have here. So this is a syntax for our easy calculation, and we run it. And there is our population density, and now newly calculated, which would now be meaningful to map. And this map now is much more meaningful than the map that we had before. Here, population densities, more apartment blocks, smaller lots altogether, tells you more something about the distribution of population density across Lethbridge. One last thing I want to show you is the statistics field in our table, which is very meaningful. Let's open this up. And if I go to my field and I right click, here is a statistics button, and let's click it. And let's make a bit more space. And here's our statistics information, and here is at the same time also a statistics graph. So a whole bunch of things are happening here. First of all, here we can of course choose whatever field in the table we want to display the statistics for. But we can also add here, for instance, mean is by default on. So we have here actually is our mean value. Our median value is then over here. And we can also actually display the standard deviation here. And we can also actually add, if we wanted to, add the normal distribution of our data over here, if you wanted to do that. Total number of counts, min, max, the sum, or meaningful information. And what's interesting also is that there's a link now between the graph, so I can choose the graph, and now it would tell me which of these polygons have certain attributes. So for instance, here, one of my highest population densities areas would be these ones here. And again, you can now make a spatial query based on your statistical data. And in the same way, we can also go here and select on our map, under map, select, and if we select here polygon, we know where it is relative to all the others. That again also is very meaningful for data query and analysis. That's it for today. I'll see you next time.